In exercise 7.1 of the Ljungqvist Sargent textbook, we have an optimal linear regulator problem, a problem which can be solved very effectively in the optimal linear regulator framework. We have the following matrices. We don't need to pay attention to the details of the problem, to the context. At this point, we only need the matrices and the vector of parameters which are given. Solving this problem takes the solving of a Riccati difference equation, which you can solve by downloading a small program from Tom Sargent's webpage. You can use this small program in Matlab, and it works perfectly. But let's try to work out an own Riccati equation solver on the basis of the idea that Ljungqvist and Sargent puts. We have this Riccati difference equation, and as j goes to infinity, there is a convergence. So we are going to find a fixed point, which is a matrix P that solves this Riccati difference equation. So on the basis of this idea, hopefully we can set up an algorithm, an iterative algorithm that iterates on this equation, and eventually we will find a matrix P that solves this Riccati difference equation. Okay, let's try to write our own code, our own program to solve Riccati difference equations. Let's start a new live script, and let's start with the parameters. We have 6, A0, which is 100. We want to check if the result is correct, so we need these parameters, because in the previous slide you saw that using the official program we have an official solution, so we can check if our own application works. 100, 0.05, 0.95, 10, 95.5, 0.95. Okay, and let's take a section break and let's go on with the matrices. Okay, A 1, 0, 0, it is the first row. Then 0, age 1, age 0, and the third row 0, 0, 1. 1, 0, 0, oh, 1, 0, 0, 0, age 1, age 0, 0, 0, 1. Okay, B. This is a column vector R 0 minus A1 over 2, A0 over 2. This was the first row, A0 over 2. The second row minus A1 over 2. It is supposed to be symmetric. A0 over 2, 0, 0. Okay. Okay. Q is very simple. Minus D over 2. We don't need to give it as a 1-1 matrix, but why not? Okay, and here we can run the script to have everything ready to apply, to be applied. And let's go on with the iterative algorithm. Okay, first let's set a huge number as a maximum number of iterations. Maximum number of iterations, and we need to think about a stopping order, a stopping command. So this is tolerance. When the difference between two consecutive matrices falls below this threshold, we want to stop the algorithm. And this is the vector, and this is the vector in which we will collect the differences. So the stopping command is going to be based on the elements of this huge vector. Okay, so let's start the for loop. We start with 2 because we give an initial guess which is going to be 0. So this is our initial guess in the Riccati equation. This is the initial guess, and by these notations we can create numbered sequence of matrices. So here we simply describe the algorithm, the Riccati equation, A prime r plus beta times A prime times P I minus 1. So we can work with this sequence of consecutive matrices, and the for loop will use the outcome of the previous step as an input to the next step. Yeah, pi minus 1 times a minus beta squared times a prime times p I minus 1 times times b times, here comes the inverse of q and beta times b prime times p I minus 1 times b. Yep, q plus beta times b prime pi minus 1 times b times b prime times a. I think we are done. So this is the Riccati equation on which we are going to iterate to find the fixed point. Okay, and let's work with the difference vector. So we work with matrices, and we want to stop the algorithm when the largest of the two differences, 9 differences actually, because it's a 3-3 matrix. So the largest of the differences falls below the threshold. Yep. And we want to take into account all the differences. So we want a vector. So this step will calculate the maximum of the absolute differences between the elements of the consecutive matrices. And we will give an order to Matlab to stop when the difference falls below this threshold. Okay, hopefully it is going to work. So let's take a section break and let's try to find the solution, the fixed point. We are looking for that index where the difference vector becomes 0 for the first time. This is going to be the index of the position in which the difference vector is going to be 0, and the fixed point of the Riccati equation is going to be in this position. Okay, and let's calculate the solution, which we can compare to the solution, the official solution published in the solutions manual. P prime times P fixed point times B times B prime Okay, I think we are done. I'm just double checking. Okay, fingers crossed. Let's run the application. It seems to be working. It takes a couple of seconds to get to the solution, which hopefully is going to be the solution we are looking for, we are waiting for. And here we are. You can see the solution F is the same as we were waiting for. This is consistent with the official solution of the textbook, so I think we are justified to say that we have made a good job. So that's all for today.